Off you go.
No point being fragile with it. Right now, we'll just get the boat in the water.
Welcome to the second video of our series designing this GPS-guided autonomous depth mapping boat designed to search, explore and map the underwater terrain. In the last video, we put the boat out on the canal and the river. We tried the new holes and tested the new camera. We discovered some design faults and some improvements that we need to make. In this video, we'll be changing the hulls once more and upgrading the propulsion. The plan is to make it more powerful and much more quiet. And honestly, I'm quite excited to see what happens. We're gonna have some threaded inserts here and here and put in some bolts through these points. Now we're gonna be filling the hull with a 2-part polyurethane foam. Absolute pure chaos, don't ask any questions. Now, to put it in context, this is the hull that we have now. This is the hull that we started with, and this is the hull that we're upgrading to. Right, so we've got all the holes filled with foam. The next steps now are to add these threaded inserts. Basically, we've got some nutserts in there, and we've got the connection in like that. Now, the reason for this, if we ever need to replace one part of the hull, we can, and it fitted on the 3D print bed. There you go. One hull is complete. That's pretty solid. One down, one to go. Very happy of how it's going so far. I'm gonna go away now and just sand them because that's a really boring part. For the next part, we're gonna be adding these rails. As we spoke about in the last video, what we're gonna be doing is adding these rails so we can change the center of mass on the hull. Oh yeah, and I thought I'd say in the process of taking this apart, if you wondered how much of a design fault these joins actually are that we mentioned and we had an issue with in the last video, this is the design fault. This is the rail that the actual boat is going to sit on, and this will be able to move so we can change where the weight is. And also, I think going to be really useful to be able to take this part off for transport. Now that we've got the holes sorted, we can start assembling the rail. So the rail consists of these blocks that fit into the end of the carbon fiber tube, and then these blocks which go over the whole tube. A very solid block. We've now done the bars, and we can demonstrate how it's actually going to go together. I'm hoping that it's going to all fit on the screen. There you go. So these are the rails. The big thing is it's pretty heavy. We've now got the holes together, and we've got this part which is the actual brain, which has got all of the electronics in. So we're upgrading the motors, but I think for now we're going to leave the 35 amp ESCs that are already in it. If we start to have heat issues, then I think we'll upgrade to 45 amps, but realistically we don't want to be using that much power anyway. You've got this plate, which is TPU rubber, fits into this part here. These screws with some rubber TPU washers, again with a slight guideline that comes through the bottom, through both of the pieces of rubber, and then into the hull. The goal of this is that this bracket doesn't ever come in direct contact with the boat itself. This is to kind of try and limit and reduce the amount of vibrations. We're going to start by assembling these as much as we can and then attach them to the boat. Right, so we've got both the mounts set up. So the next step is to join it onto the hull. Right, so that is what we've got. Undoing this side of the tubes. There you go. Oh, we'll put these back in, starting to come together a bit. Right. It's got some weight to it. Right, all the screws are in. Next step is to chuck the wiring in. Right, we've got our cables in the Wago blocks, so now to put the lid on and test it, I guess. We'll get our battery in. Cool. We've got the blades how we expect them to be. Now, which way are they blowing? Opposite. And another pair switch. This is the advantage of these Wago blocks. Nice. I was going to test this in the bath, but it won't fit in the bath anymore. So it's just going to be testing out on the water. Move this into the dead center and try and get the balance right, but I don't need that on film. And we're going to seal everything up, make sure all the bolts are tight, and get to some water. Right, so we've just gotten to a lake, because I thought that as opposed to a canal and a river, a lake might be the best thing really to take the boat out on, but the weather doesn't look great. I'm not so worried about the slight amount of rain, but it's more so, will the boat be able to deal with the waves? It depends really from like minute to minute, but some of these waves that are coming in are quite big. We're starting our initial tests without it connected to the controller. This is just to see whether the boat is going to sit correctly in the water. We want to make sure that it's not sitting on one side and that it's not going to sink if it doesn't have the correct buoyancy. For this, I'm just going to begin putting pressure on one side, holding it down and seeing how much weight it takes, whilst also checking that there's no bubbles that are going to be released. As I said before, I couldn't test it in the bath, and I have to make sure now that it's not taking on any water into the hull. If it takes on water into one side, it could easily unbalance it and let it tip over. We're now just putting some shock on it and making sure that it seems stable. Right. Is it engaged? At this point, I just want to make sure that the controller is actually controlling the boat and everything is going to react as it should be. I'm a bit concerned at this point that when I go out, it's just going to lose connection and slowly float away. Yeah, look at it hit the waves. I reckon it's a lot faster. Oh, look. Ooh. Oh, it's fucking spot on. It's like it's less choppy but bigger waves at the moment. Look at that. You want to just send it, don't you? That's the thing. But we can't at this stage.
we've just finished the first test, and it actually handled the water a lot better than I thought it would. We've just gone over some checks, some tightness checks, and everything seems fine. There's no water on the inside, although you probably can't see very well, and there wasn't any water inside here. Of all of the time that we're testing, I imagine it's been out on the water at least 30-40 minutes, and it's only gone down 0.3 of a volt, so I don't think we really have an issue about battery life either. I'll have to try and calculate how long it would last based on that, but it has been fighting a lot with the waves, as you'll see. But the holes seem to stay buoyant and cut through the wave or stay over the top of the waves, and it doesn't look like one side sitting lower than the other, so I don't think we're letting in any water. I'm going to call that a successful mission. Next steps are to test it on some waypoint missions, maybe on some less choppy water first, and chuck the fish finder on the back so we can see some depths of where we're mapping. We still want to take it out on a lake, I think, because you have much more interesting depths within a lake, but we'll get there next. That'll be the next part.